Hi everyone, good afternoon. My name is Inge. I am a PhD student and I will tell you a little bit about part of my PhD thesis that is incorporated into a project called PCAT for cod, and it looks at the effects of seismic survey on the behavior and movement of cod. So first of all, what is a seismic survey and why should we care about the effects of this on fish? When in search for offshore sources of fossil fuel, companies use a vessel that pulls an air gun behind them, which is called the seismic source, and this air gun emits a sound blast towards the seabed. This air gun source is dragged behind the vessel, and behind that there is an array of hydrophones which picks up the reflection from the seabed. And using that, images can be formed of what is below our seabed. The sound that is emitted by the air guns is very low in frequency and can be heard by many marine fish, including cod. So how do we track an animal that's in the sea? Well, GPS signal doesn't travel through salt water, so we use something else which is called telemetry. With this technique, a tag is inserted into the fish, which emits a signal, and with this signal, we get information on the presence, the position, and sensor data, which in our case includes information on the depth of the animal through a pressure sensor and the overall acceleration of the animal through an acceleration sensor. And where do we study the behavior of cod? Well, previous studies have shown that cod reside in areas where there's structure, which is like an offshore wind park, and they spend prolonged periods of time there. So what we did is put a bunch of hydrophones that can receive the tag signal in this area, all the white dots you can see here, and we tagged 57 fish around this area. So we got data on their presence, position, and depth and acceleration use, while there was also a seismic survey going on in the area, which approached our study area up to 2 kilometers. And what does this data look like? Well, these are some first plots of what we got out of this data. Here you see the overall presence of the animals and the time on the x-axis. And the red lines indicate the period when the seismic survey took place, so when we had the sound exposure. And you see that over time there is a decreasing detection of our animals, but you don't see that there's straight away something happening within the seismic period. And when we zoom into the individual fish, so every line is a fish and every dot is when it was detected in the area, you see again that there's no immediate sign to think all the fish leave the area when the survey is taking place between the red lines. We also get information on the movement of the animals. So here you see per plot it's one zoomed into one turbine with receiver stations around that, and the position of our fish within this system. And there's a lot of change in aerial use of individuals, and this is very much bound to individuals. For example, in the lower ones, you see the blue fishes using a different area than the purple fish. But again, you don't know what that could mean yet. As well as this is what the information on acceleration looked like. So you got from 0 is they're not accelerating at that point, up to 5 when they're accelerating quite a lot, 5 meters per second. And you see that there is fluctuation in the overall acceleration through time. It looks like there could be some indication for less acceleration at the onset of the survey, right after the first red line. But you also see a definite pattern in this data, and when you overlay day and night patterns, this kind of fits that pattern well. So the gray bars are nighttime, and there's more acceleration then. So what we're going to do now is we're going to perform some further analysis on this data to get information on the spatial use of the animals as well as different behaviors they might be displaying. And we're going to correlate that to the acoustic data, so information from our hydrophones in the area as well as the position of the vessel at any certain time. And I hope to be able to show you some of the results later on. Thanks very much for listening. If you have any questions, come by later. And there's a nice VLIZ stand there which explains telemetry, so if you have questions on that, go and see them.